Okay, so we'll continue with the next part of pedigree analysis. Here we'll discuss the applications of pedigree analysis. The major application of pedigree analysis is that we can determine the genotype of a trait. We can predict the phenotype of a genotype, and also we can find out the pattern of gene expression, whether it is a dominant trait or it's a recessive trait. These are the basic application, very simple application, but very relevant. Okay, so when you consider a trait, these trait could have four possible expression status, or four possible genetic status, right? And this is based on two criteria. One is based on the genetic location, the other one based on the expression status. Okay, and when you make it more specific to a clinical condition, that means to a genetic disease, a genetic disease will have will definitely will have a genetic reason. There will be a gene behind a genetic disorder, and these gene may be either of the four type. Okay, in short, this gene will be either of the four type based on either their genetic location or based on their expression status. Clear? So based on genetic location, we have two classes. One is the autosomal trait and the other one is the sex-linked trait. You may be familiar with these terms. If that gene is located in the autosomal chromosomes, we know that we have 22 autosomal chromosomes and one set of sex chromosome, right? So if the gene is located in the autosomal chromosomes, then we classify that gene as an autosomal trait or autosomal gene. If it is in the sex chromosome, you know, we have X chromosome and Y chromosome, right? In a female we have two X chromosome, and if it is a male you have one X and one Y chromosome, right? And then that if a gene is located in the sex chromosome, then we denote them as sex-linked trait. All right. Then based on the second one, that means the expression status, we have dominant and recessive characters. That means certain characters are dominant and certain others are recessive. The concept is that a disease is recessive means a genetic disease is classified as a recessive disease. It is when this gene is in the recessive status, then that individual experience a genetic disorder. That is what that means. Similarly, a dominant disease means if that trait is in the dominant status, then the individual will experience a genetic disorder, right? So this is what dominant and recessive characters. So in short, we have all that four types. That means autosomal dominant, autosomal recessive, then sex-linked dominant and sex-linked recessive. Basically here the sex-linked dominant and recessive are representing the X chromosome, and additionally you can also include a fifth class, that is Y-linked, since it is not involved because only very few genes are located in Y chromosome, and that too is very specific in male, never in a female. That's why it's not included in this classification. Then these things already we have seen that there are 22 autosomal pair and one sex chromosome. So the pattern of inheritance, all those things I am not going into that discussion. I have already discussed in one of my videos, you can refer that. Right, so straight away we are moving into the autosomal dominant trait. So what are the features of autosomal dominant trait? So first we'll give you the basic or the very important terms related with a particular trait or a particular status. That means if the disease is autosomal dominant, then the following will be the features of that particular disease. The first one is it will occur in both the sexes with equal frequency. That means irrespective of male or female, the disease will be present. Okay, and they'll be transmitting to their offsprings, irrespective of the sex of the individual. That's one feature. The second thing, that is the most significant one, that these traits, if a disease is present in all the generations of a family, then definitely that gene will be, or that trait will be included in the autosomal dominant trait or in the autosomal dominant class. Okay, so the feature is that they do not skip generation. Okay, and the third one is also unique. That means if the parents are affected, usually the parents are affected, but for an affected parent, it is possible to have unaffected children. There is possibility for normal children for affected parents. Okay, but the reverse is not true. That means for all affected children will definitely will have an affected parent. Right, without an affected parent, a children will not be affected. But there is a possibility that a parent who is affected, it is possible to have a children without a disease. Okay, let's see the genetic experiment location. Then the fourth one is, there is one more point, unaffected persons usually do not transmit the trait. That means there is no carrier at all. If the disease is autosomal dominant, there is no carrier individuals present. Alright, then the disease condition is usually represented either by capital A, capital A. The capital A, usually we know that capital A represents a dominant trait. If the individual has both the alleles dominant, then definitely that individual will be affected. Or otherwise, at least one dominant allele is present in that individual, then he is also or she also will be affected. Okay, so either capital A or small a capital A will be the affected condition in case of autosomal dominant disease. Okay, then the no disease condition is of course small a. That means it is completely recessive. There is no one dominant trait. In that situation, that individual will be normal. Right, you can see example. A lot of examples are there. Huntington disease, you have Marfan syndrome, then non-polyposis colorectal cancers, also multiple exosteosis. So all those things are various examples. I am not going into the details of these diseases. Okay. So these are the features of autosomal dominant trait. They do not skip generation. They can be, that means the parents will have unaffected children, and this will be present irrespective of the sex. Here you can see the see the autosomal dominant trait, how it will appear. Okay, see you can see that generation 1, in generation 1 the female is affected. That means the female is having a dominant trait. Okay, for example, suppose we represent with the capital A this number 2 individual. That means this red filled individual will be having a trait either capital A or capital A small a. This will be the genetic status of individual 2. Right. At the same time, this first individual will be definitely small a. This he will be small a. This individual 1. All right. So they have 1, 2, 3, 4 children. Right. They have 4 children, and of which you can see there the individual 2 and the 6 have been affected. That means one male, here you can see this male and this female and this male is affected. Clear? And moreover, you can also see that they are present in all the generations. Right? they are present. These disease is present in all the generation. It is present in the generation 1, generation 2, 3 and 4. They do not skip generation. That's what the important feature. They do not skip generation. And the second thing was there is possibility for unaffected children. You can see the unaffected children for the affected parent, right? And also there is no possibility that an affected children, here you can see this affected children will definitely will have at least one affected parent. Clear? And these individuals usually do not act as carriers. They do not have any trait responsible for the genetic expression of that trait. Clear? And we can check that. We can check the status. Okay, so suppose this is capital A, at least one capital A is present in that, then there is possibility, and definitely here it is small a in this individual. So suppose you consider this individual 2, what will be the genetic status? So there should be at least one capital A, so that will be contributed by this mother, and a small a will be contributed by the father. Okay, so it is possible that this individual is having one capital A. And when we look at this individual, again the same way, this capital A will be contributed by this mother, and this small a will be contributed by father. So it is possible to have affected son and daughter. Okay, and similarly we can also check this one, individual 3, who is not affected. So this individual 3, it is possible to have the small a from the mother. That means there is a small a and a small a from the father also, right? That means it is also possible to have unaffected children, unaffected daughter and unaffected son is possible. Okay, so these are the possibilities for autosomal dominant trait.